Hello and welcome to another video. I found this integrals problem in one of the previous board exam question papers. Initially, I found it really tough to solve, and I would admit that if you have not solved it before, it would be tough to think during the exam, in the heat of the exam. I somehow found a method to solve it, and I wanted to demonstrate it for you. We'll get started on this question. So root of x divided by 1 plus root over x power 3 by 2 dx. To start with this, I thought we'll convert all the root of x and root of x power 3 by 2 into fractional powers. So integration of x power 1 by 2 dx, the whole divided by 1 plus x power 3 by 2, the whole power 1 by 2. So this can further be written as x power half dx, the whole divided by 1 plus x power 3 by 4. So to start with this, I thought we'll find a common factor between power half and power 3, this power 3 by 4. So 1 by 2 could be written as 2 by 4, and this power 3 by 4 could be written as just 3 by 4, and the common factor between them was 1 by 4. So I thought we can give t is equal to x power 1 by 4, and x becomes equal to 4t power 4. To convert dx, I'm writing x is equal to t power 4. So using this, x power half becomes t square using this again. And x power 3 by 4 becomes t cube. So the whole integration now becomes I is equal to x power half is t square dx. Now dx is equal to, I'm writing it here. So dx is equal to 4t cube. So t square into dx now becomes 4t cube dt, the whole divided by 1 plus x power 3 by 4, 1 plus x power 3 by 4 is 1 plus t cube. Now you can find there are t cube terms and there is one t square dt term. Okay. So now I'm going to give one more substitution variable. Y is equal to t cube and dy is equal to 3t square dt. Now we can replace all the terms here. So t square dt becomes dy divided by, so dy divided by 3, and 4t cube dt. So 4t cube, this can be written as 4y dy, the whole divided by 1 plus t cube. So 1 plus t cube is just 1 plus y. And integration becomes easy from here on. So y dy divided by 1 plus y. So you can add plus 1 on the numerator and minus 1 on the numerator, and split the common denominator between the terms and solve from here on. But then I realized instead of using two substitution variables, one as t and one as y, why not use one single substitution variable? I thought that would be more efficient than this method. So we have written it as t is equal to x power 1 by 4, and further y is equal to t cube. So why not use y is equal to x power 3 by 4 itself, to start this whole question with y is equal to x power 3 by 4. So that would mean just using one substitution variable. Write this as integration x power 1 by 2 dx, the whole divided by 1 plus x power 3 by 4. So as said before, I'm going to write this as y is equal to x power 3 by 4. So x here becomes y power 4 by 3. So now x power 1 by 2 can be written as integration of y power 4 by 3 the whole power 1 by 2 dx can be written as 4 by 3 into y power 1 by 3. So 4 by 3 into y power 1 by 3 the whole divided by 1 plus x power 3 by 4 can be written as y power 4 by 3 the whole power 3 by 4. So this becomes integration of y power 2 by 3 on top, and I'm taking this constant outside. So 4 by 3 goes outside, so I should have written dy here. So 4 by 3 into y power 2 by 3 into, so y power 1 by 3 into dy, the whole divided by 1 plus y. So this becomes 4 by 3 into integration of y divided by 1 plus y. From here on, we can just add 1 and subtract 1, and this is equal to 4 by 3 y plus 1 by 1 plus y, the integration of 1 minus 1 divided by 1 plus y. This is equal to 4 by 3 integration of 1 with respect to dy becomes, so 4 by 3 integration of 1 is y minus log of 1 plus y. So this can be written as 4 by 3. So I'm going to replace y in terms of x again. So y is equal to x power 3 by 4. So 4 by 3 into x power 3 by 4 minus log of 1 plus x power 3 by 4. That's the final answer.